Hi, welcome to InfiniBand Key Features training session. In this video, we will learn about InfiniBand key features. NVIDIA Mellanox InfiniBand Interconnect brings high-speed, extremely low latency, scalable solutions. The InfiniBand technology enables supercomputer, artificial intelligence, and cloud data centers to operate at any scale while reducing operational costs and infrastructure complexity. In this video, we will see what are the key features that make InfiniBand the interconnect technology of choice for AI, deep learning, data science, and many other accelerated computing applications. Simplified management, high bandwidth, CPU offloads, ultra-low latency, easy network scale-out, quality of service, fabric resiliency, optimal load balancing with adaptive routing, MPI super performance with Sharp, a wide variety of supported topologies. First, let's start with simplified management. InfiniBand is the first architecture to truly implement the vision of SDN, software-defined network. An InfiniBand network is managed by a subnet manager. The subnet manager is a program that runs and manages the entire network. It provides centralized routing management, hence enables to plug and play all the nodes in the network. Every InfiniBand subnet has its own master subnet manager, and in order to ensure resiliency, a second subnet manager functions as a standby. The next InfiniBand key feature presented is high bandwidth. Let's see how InfiniBand's bandwidth has evolved over the years. InfiniBand architecture began its journey in 2002 with a speed of 10 gigabit per second, and since then, it has been providing the highest bandwidth, non-blocking bidirectional links. The next key feature, and definitely one of the most important ones for accelerated computing applications, is CPU offloads. The InfiniBand architecture supports data transfer with minimal CPU intervention. This is achieved thanks to hardware-based transport protocol, kernel bypass or zero copy, and remote direct memory access. RDMA is the direct memory access from the memory of one node into that of another without involving either one's CPU. Offloading compute nodes can be implemented by NVIDIA GPUs as well. GPU Direct allows direct data transfer from memory of one GPU to the memory of another. It enables accelerated computing applications such as AI, deep learning, and data science, lower latency and improved performance as provided by the GPU-based computation. Now, let's move on to latency and see how InfiniBand latency is incomparable to any other interconnect technology. Extreme low latency is achieved by a combination of hardware offloading and accelerating mechanisms, which is unique to the InfiniBand architecture. As a result, end-to-end latency of RDMA sessions can be as low as 1000 nanoseconds or 1 microsecond. What about network scalability? To which size an InfiniBand subnet could scale to? One of InfiniBand's main advantages is the capability to deploy up to 48,000 nodes on a single subnet. Having said that, multiple InfiniBand subnets can be interconnected using InfiniBand routers in order to easily scale up beyond 48,000 nodes. So far, we have a scaled-out InfiniBand subnet that is easily managed by the subnet manager and is capable to provide high bandwidth and low latency with CPU offloads. Hopefully, you are already impressed by those great features. But hey, what happens if there are different applications running in the subnet and we would like to prioritize some applications over others? In other words, is InfiniBand capable to provide quality of service? Quality of service is the ability to provide different priority to different applications, users, and data flows. Applications that require a high priority will be mapped to a different port queue, and their packets will be sent first to the next element in the network. Everything sounds great when the network is stable and there are no failures. Next, we will cover the features that allow InfiniBand to cope with failure and allow close to incomparable network continuity. One of the main features that customers require is a stable network without link failures. In such cases, traffic resumption must be very fast. When traffic reroute depends solely on the subnet manager routing algorithm, traffic renewal can take around 5 seconds. NVIDIA InfiniBand solution features a mechanism called self-healing networking. Self-healing networking is a hardware-based capability of NVIDIA switches. NVIDIA self-healing networking enables a link fault recovery that is 5,000 times faster. This means the recovery time takes only 1 millisecond. Another requirement that should be addressed in a modern high-performance data center is how the network is best utilized and optimized. One way to achieve that is to have a load balancing scheme. Load balancing is a routing strategy that allows traffic to be distributed over multiple available paths. Adaptive routing is a feature that allows equalizing the amount of traffic sent on each one of the switch ports. Adaptive routing is enabled on NVIDIA switches hardware and managed by the Adaptive Routing Manager. When adaptive routing is enabled, the switch queue manager constantly compares the volume levels between all group exit ports. The queue manager constantly balances the queue's loads, redirecting flows and packets to an alternative, less utilized port. To sum up, adaptive routing may be activated on all fabric switches. Adaptive routing supports dynamic load balancing, avoiding in-network congestion, and optimizing network bandwidth utilization. NVIDIA's intelligent InfiniBand switches also support an in-networking computation technology called SHARP, Scalable Hierarchical Aggregation and Reduction Protocol. SHARP is a mechanism based on NVIDIA switch hardware and a central management package. SHARP offloads collective operations from the host CPUs or GPUs to the network switches and eliminates the need to send data multiple times between endpoints. SHARP decreases the amount of data traversing the network. As a result, SHARP dramatically improves the performance of accelerated computing, MPI-based applications such as AI, machine learning, and others by up to 10 times. Last but not least, InfiniBand provides a rich array of supported topologies options, including FAT-Tree, Torus, Dragonfly Plus, Hypercube, and HyperX. Being able to support a wide variety of topologies, InfiniBand answers different customers' requirements, such as easy network scale-out, reduced total cost of ownership, maximum blocking ratio, minimum latency between fabric nodes, and maximum distance. In this session, we have described the main key features that make InfiniBand the most high-performant, effective, resilient, and best utilized interconnect technology for accelerated computing applications in modern data centers. Simplified management by the subnet manager, high bandwidth, CPU offloads and RDMA, end-to-end best-in-class latency solution, fabric scalability, quality of service by traffic prioritization capability, resiliency and fast rerouting of traffic in case of a port failure, adaptive routing providing optimal load balancing, eliminating in-network congestion, in-networking computation based on NVIDIA's Sharp mechanism, and a wide variety of supported topologies. In our next video, we will learn about InfiniBand architecture and management.